In this video, we're going to look at solving equations with trig functions. So here we have one that's actually a fairly basic one, even though it looks pretty cumbersome. If we look at the general shape of it, it looks a lot like the quadratic equation that we're used to, or a form that we're used to. That looks like this. It's something squared plus 3 times that something minus 4 equals 0. And as a quadratic, we know how to solve that because we can factor it. So that would factor as, that would factor as x plus 4, x minus 1. So we know the product is negative 4 and they add to be positive 3. And then we would have x plus 4 equals 0, x minus 1 equals 0, and we would get negative 4 and positive 1. So over here with the signs, it's really the same thing. We're just substituting x for sign. So just think of x as kind of like a placeholder. Then it's the same idea over here. This could factor as sine theta plus 4 and sine theta minus 1. And then we've got something times something equals 0. We can break that up. So we've got sine theta plus 4 equals 0. And we've got sine theta plus minus 1 equals 0. And of course we move the 4 and the 1 to the other side. So we've got sine theta is equal to negative 4, and we've got sine theta is equal to positive 1. So we see that over here we had our solutions. We don't quite have our solutions here, but it's the same exact shape of the equation. So now we need to solve the smaller equation, sine theta equals negative 4 and sine theta equals 1. Now remember, for sine you can only get numbers from negative 1 to positive 1, so we can't ever have sine theta equals negative 4. You could try putting this into your calculator. Maybe you just thought it was a value you didn't know, and you just thought you could put in sine inverse, and you're going to get error, which means no solution. Let me write that a little bit better. Okay, so from this piece of the puzzle, you may recognize it right here, or you may actually try to compute it, but you're going to get no solution from that piece. Okay, over here, sine theta is equal to 1. You can either look at your graph of sine, or you can look at your unit circle, and we know that sine is equal to 1 at pi over 2. Okay, and that's the only place on 0 to 2 pi. I didn't put that in the directions, but we're just going to start off solving 0 to 2 pi. That's the only place from 0 to 2 pi that we're going to be equal to positive 1. Okay, so there's one example. So let's try another one. Okay, let's say that we have 2 sine squared theta minus square root 3 sine theta equals 0. Okay, so using our same strategies that we would have had in, say, college algebra, remember you always want to look for common factors first, then you want to look for binomial factors, and then usually if it's something more complicated than that, we're going to go to the graphing calculator. We'll look at that in just a minute. So here we see that we've got a common factor. Okay, don't forget to look for those because that's the easiest kind. We've got a common factor of sine. So if I take one sine out, I'm left with 2 sine theta minus square root of 3 equals 0. And now I've got something times something equals 0. I can break that up. I've got sine theta equals 0. And I've got 2 sine theta minus square root of 3 equals 0. So solving sine theta is equal to 0. So places where sine is 0 or hits the x-axis, that's going to be at 0 and at pi. And then again, it would hit at 2 pi, but remember our interval is usually 0 to 2 pi, not included. Okay, so one trip around the unit circle. And then, so that's our one set of solutions. That's a 0 there. It kind of looks like a 6, but you guys know what I mean. All right. And then our other one over here, we're going to solve for sine theta. So we move that square root of 3 over, and we divide by 2. Okay, so we get sine theta is equal to square root of 3 over 2. And we look at our graph, or we look at our unit circle, and we know that that's going to be at pi over 3, or 60 degrees, depending on whether you want radians or degrees. And that's the first place that sine is equal to positive square root of 3 over 2. We also know that sine is positive in the second quadrant, so we would also have 2 pi over 3 or 120 degrees. Okay, so we use that first angle as our reference angle for quadrant 1, and then we do the same thing for quadrant